left. We're going to tackle the question, well, what is modern science? And again, this will give us, I hope, a great deal of clarity. And I want to describe modern science using these 5 categories: scope, objective, mindset, method, and outcome. Now, a scope, I think of as the reach of science. What's the reach? What's the domain? The objective is, well, what's to be done? By mindset, I'm thinking about what's the deliberate attitude or approach that science adopts. By method, I'm talking about the orderly way science proceeds, and the outcome is what's the specific result we're after. And so here's how I think about it. Let's start with scope. Excuse me. I describe the scope of modern science as the entire physical realm consisting of matter, energy, time, and space. And about the time I was retiring from the laboratory and beginning to read about science, it dawned on me that all the measurements we made in the many decades I worked at NREL, the units of those measurements were always matter, energy, time, and space, or some combination of the 4. And it was pretty interesting to think about. That's what science is looking at. Certainly the whole earth, the whole universe, but it's that realm made of matter, energy, time, and space. Now, for me, this begs the question, what then is outside the scope of science? And it turns out there's a lot of important things that are outside the scope. And this is where a good understanding of science is really helpful. For instance, the question, what is good and evil? Well, if we're going to study matter, energy, time, and space, we're not going to get a lot of help discerning questions of morality and ethics. We're not going to know what is good and evil. Science can't help us find a basis for human dignity and human rights. That's got to come from some other area of human knowledge. The study of the physical realm just isn't going to get us there. Or think about this, the human experiences of love, joy, beauty. These are subjective things that are beyond the reach of science. Yes, science can study what humans think about these things, but it really doesn't help us define what love is or what beauty is. The question of human purpose, significance, and meaning. Again, that's something that's outside science. We've got to turn to philosophy, religion, other areas of human knowledge and thought. Or how about this? The existence of God, the existence of the supernatural. If the gods were made of matter, energy, time, and space, science could study them. But we Christians hold by faith that God is spirit. Science can't go there. Science can't observe or measure spirit. And the surprising thing is that things like mathematics and logic are also outside science. In fact, humans brought mathematics and logic to the task of science. It wasn't science that created those disciplines. So this is pretty helpful for us to think with clarity. What is the scope of science, but also what's outside the scope of science? Let's move on. That was scope. Let's talk about objective. In my view, the objective of science is the systematic observation of the physical realm, which we just described, that's the scope, systematic observation of the physical realm in order to know the laws of nature. That is the goal, to understand how nature behaves, the laws of nature. And the third one is mindset. And in science, the mindset it's this kind of jargon. It's called methodological naturalism. But what that means is, remember, this is the deliberate attitude that science is going to use. Methodological naturalism means science intentionally focuses on and limits itself to natural causes. Explanations based on the supernatural, the gods did it. Explanations based on authority figures, that's what Aristotle taught. Explanations based on traditions, we've always done it that way. No, that's not what science is going to do. They're going to look for what in nature caused the effect that we're observing and measuring. And that, the technical term or the philosophical term, is called methodological naturalism. We're going to limit ourselves to natural causes. That's the key. The fourth category is method. And this is the classic scientific method. I think this is going to be familiar to all of you. I describe it in this way: observation, excuse me, followed by forming a hypothesis, and then testing the hypothesis, usually with experimentation. After experimentation, then there's an evaluation: reject, modify, or keep the hypothesis, and then repeat. And this is, I think, a reasonable description of the classic scientific method. It includes reliance on observation, measurement, and experiments. And the results are typically published in peer-reviewed journals, which I hope you guys have heard about before. But what that means is that a scientist who has a new finding, he will submit it to the editors of a journal. The journal will get it reviewed and critiqued by other scientists who have expertise on the topic being reported, and can check that good methods, proper logic, good mathematical methods have been used, good experimental methods have been used, all those kinds of things. So the use of peer-reviewed journals is an expression, I think, of the skepticism that Francis Bacon taught way back in the 17th century. And this is one of the ways scientists deals and tries to be critical and review and critique the work to make sure it's sound. And one of the key things we're looking here in the scientific method, excuse me, I'm having a little trouble tonight, is that whatever one scientist found, it needs to be repeatable by others. And only then will the larger scientific community adapt and accept that finding as reliable knowledge. Okay, the final category is outcome. And this one is really interesting one to think about. The outcome of science, in my wording, is this: a thoroughly and repeatedly tested hypothesis can, in time, gain consensus as a theory, which is a hypothesis that science fails to reject. And I hope you'll take that phrase with you. A scientific theory is a hypothesis that science fails to reject. A theory is a description of one of the laws of nature, usually expressed in mathematical terms. Theories are models and approximations of how the physical realm works. They're not the real thing. So a theory, Newton's formula for his law of gravity, that's an expression, a mathematical approximation of gravity. But it's gravity is the real things we observe, say how things fall to the earth. That's the real thing. I want to open up these two words, hypothesis and theory, just a bit. So a hypothesis comes from the Greek. And hypothesis, hypo means less than, and thesis, you might guess, means a theory. So hypothesis is simply less than a theory. A hypothesis starts with an educated guess, and then it gets tested. And an hypothesis must make a prediction. Hypothesis, a sound scientific hypothesis must predict how nature is going to behave in the future. And that makes the idea testable and falsifiable. Now let's look at the idea of a theory. A theory no longer means that the scientific idea is an educated guess. A theory is the best available description of a particular event in nature or a general law of nature. And even when theories have been established, they continue to be held with some skepticism. And I appreciate these quotes from Einstein. I think he understood this idea clearly. Einstein said scientific theories are never completely final, always subject to question and doubt. You can just hear the skepticism there that Francis Bacon wrote about centuries earlier. Einstein also wrote, "No amount of experimentation can ever prove me right. A single experiment can prove me wrong." And it's this idea right here that scientific theories aren't so much about having been proven, but they could be proved wrong in the future. So that's why I describe a theory as a hypothesis that science has failed to reject so far. I also think that it's fair to say that science is not about proof, about certainty. We just accumulate the best available descriptions of how nature functions all around us. So there's all five. Scope, objective, mindset, method, and outcome. And I hope that clarifies in some ways what science is and what it's not. And hopefully this will help us think clearly about the interface of faith and science.